Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 4th, 2025, just yesterday. This paper introduces a new large-scale language model for code that achieves a remarkable inference speed of 2,146 tokens per second. The paper is titled Seed Diffusion, a large-scale diffusion language model with high-speed inference, and it really pushes the state-of-the-art for the trade-off between speed and quality. It does this using a technique called discrete-state diffusion, which allows a model to generate text in parallel instead of sequentially one token at a time, overcoming the slowness of traditional models. And as you might expect for a paper with such big claims, it's already making waves on social media. We're seeing some reactions on X, with one user highlighting the core finding, quoting directly from the abstract about that impressive speed of over 2,000 tokens per second on H20 GPUs. The post also notes that this speed comes while maintaining competitive performance across standard code benchmarks. It's already picked up over 100 likes, so clearly that combination of speed and quality is catching people's attention. Alright, and this first figure really visualizes that core claim. Across the coding benchmarks on the left, you can see the new model, shown in purple, holds its own against the competition, achieving very similar scores. But the dramatic difference is on the far right, in the speed comparison. The bar for the new model towers over the others, hitting that incredible 2,146 tokens per second, a huge leap in efficiency for that very competitive performance. So how do they achieve that impressive speed? These next two charts explore some of the training dynamics. The plot on the left shows the speed up during a special phase called on-policy training, where the model learns to find the most efficient ways to generate code. You can see the speed-up ratio climbs dramatically, reaching over 400%. Then, the chart on the right shows the trade-off with block size. The model generates in parallel chunks, and as those chunks get bigger, the time per step increases, showing a balance between parallelism and computational work. This table then details the performance on two specific code editing benchmarks, Aider and Canit-Edit. And what's really interesting here is the result for the Canit-Edit benchmark. The new model, Seed Diffusion Preview, scores 54.3, which is the highest score in its category of models under 15 billion parameters. In fact, it even outperforms some of the much larger models shown in the bottom half. This result really highlights that the incredible speed doesn't come at a major quality cost. For certain tasks, like code editing, it's a top performer. And looking at another benchmark, this one for multi-language programming problems called MBXP, we see a similar story. The new model, Seed Diffusion Preview, scores a 72.6 average across all languages. This is very competitive within its size class, right alongside models like eCoder and QN 2.5 Coder. It's not the absolute top score, but this result confirms the model achieves strong performance to go along with its breakthrough speed. This next table shows performance on the natural code bench, which tests how well models generate code from natural language descriptions, in both Chinese and English. Here, Seed Diffusion Preview scores a 42.2 overall. This is another very solid result, keeping it competitive with other leading models in its size category. It's right in the mix with models like eCoder and DeepSeek Coder, reinforcing that its speed is paired with robust, high-quality performance across different kinds of coding tasks. So to wrap things up, this work really establishes a new frontier for efficient code models. By using a technique called discrete-state diffusion, which learns to generate code in parallel rather than one token at a time, Seed Diffusion Preview achieves that incredible speed without giving up quality. It truly sets a new state-of-the-art on that speed versus quality curve. That's it for this episode of